Notes 13, page 4. This page, you should come back to it frequently because we've done a few examples. I'm going to try to put all the basics together, and I tried to sort of show you some steps so you have a process here for adding and subtracting rational expressions. First thing is you avoid canceling terms. If you cancel terms, like trying to cancel these x squareds up here, I will show no mercy. We will factor all denominators. That'll be your first step. And you want to note the restrictions after you factor, but before you cancel or build the LCD. It's really hard to tell what the restrictions are here, but once we factor these, it'll be easy to tell. So once you factor the denominators, not the numerators, we don't factor numerators because we want terms in the numerator so we can add numerators. Once you factor the denominators, you build the LCD from the prime factors of the denominators, kind of a two-step process. For the coefficient, just eyeball the LCD. For the variable factors, your LCD has to have every variable factor that you see in all the denominators. If a variable factor shows up more than once, use it with the largest exponents. Once all the fractions have the same denominator, so that's the process where you're going to multiply top and bottom by the same number. You can add the numerators. One caution here is to make sure you distribute negatives through numerators. That's a common careless error. And then finally, you're going to want to check to see if your final answer reduces. So I guess one thing I didn't put down here is once all the fractions have all the same denominator. I didn't really describe how to do that, but for that, let's sort of add that in. You multiply top and bottom by the same thing. That's how you get the fractions to all have the same denominator. All right, so now we're ready to look at this one. So I want to add these two fractions. The first thing I'm not going to do is cancel terms. The first thing I am going to do is see if my denominators factor. The x plus 5, that doesn't factor. I need to build denominators from factors of the denominator, so I'm going to scoop x plus 5 in parentheses and say that's my factor. This denominator, no GCF, does look like it comes from FOIL. I know it's x and x. I know it's plus and plus. And then I'm thinking 5 and 3. Yeah, there it is. Okay. Now, building the LCD. The only coefficients are 1, so don't have to worry about that. That coefficient will be 1. I see two different variable factors. I see x plus 5 and I see x plus 3. So both of those factors have to be in my LCD. The x plus 5 is the one that shows up in two places. But the biggest exponent you see it with is 1. So that's the exponent we use in the LCD. The x plus 3 only shows up in this denominator. It shows up as with an exponent of 1, so that's how we use it there. So that's my LCD, x plus 5 times x plus 3. Now, adjust each fraction so it has the LCD. And how you do that is think about what factor's missing. So you look at the denominator you have, you look at the denominator you desire, what factor's missing? The x plus 3. And let me copy this denominator over. Oops, it's x plus 5 times x plus 3. So for this fraction, this is the denominator I have, this is the denominator I desire. I always think of playing Go Fish. I got what I wanted. I don't need to mess with that fraction. Now, this is the step where you really have to understand what's going on with adding fractions. We add numerators. You also gotta understand what's going on with addition. When we add terms. So if I look at this numerator here, those are factors. I need to distribute in the numerators because I need to get back to terms. Try to get my words run together. Distribute in the numerators only. I will never add the denominators. I do not want to waste my time distributing in the denominators. So this is a FOIL problem. So what is it? 2x squared plus 6x minus 3x minus 9 all over x plus 5 times x plus 3 minus x squared minus 4x minus 19 over x plus 5 times x plus 3. Okay, now I realize there's something I forgot to do. Forgot to look at the restrictions. Anytime during this process you can look for restrictions. You want to look for it before you start reducing anything. So I'm going to look at the denominators. X plus 5 is in the denominator. I can't let that be 0. If x was the opposite of 5, that would make that 0, so x cannot be negative 5. And I can't let x be negative 3. Same thing over here. So these equals are going to hold as long as x is not negative 5 or negative 3. All right. Now that I have common denominators and I have terms in the numerator, I'm going to add the numerators, but I got to remember to distribute the negative. That is the most common careless mistake that I see. So this will be 2x squared. Now I'm going to be a little lazy here. I'm just going to add those. That's plus 3x minus 9 minus x squared plus 4x plus 19 all over x plus 5 times x plus 3. And you see why I want terms in the numerator? I want to be able to cancel like terms. So 2x squared minus x squared are combined like terms. 2x squared minus x squared is 1x squared. 3x plus 4x is plus 7x. Negative 9 plus 19 is plus 10 over x plus 5 times x plus 3. Notice I've got, it's all one fraction now, it's all one term, but, and this hasn't happened really yet, this is the first time we've had to do this, sometimes when you add fractions you can reduce your answer. Only at this final stage do we want to think about factoring the numerator. Because if I could factor this numerator and I get an identical factor, then I could reduce it. And it turns out that does happen. Because I can see that this numerator factors as x plus 5 times x plus 2 over x plus 5 times x plus 2. Oh, x plus 3, silly me. Can't even copyright. The x plus 5s are identical factors. So this nasty mess comes down to x plus 2 over x plus 3. So if I plug in a number for x like 5 here, it's the same thing as if I plugged it in here, except if I try to use negative 5 or negative 3. And remember, we talked about this. You don't see negative 5 as a restriction here, but this remembers its history. It came from this original expression, x cannot be negative 5. So If you plug in -5 here, you get undefined. You plug in -5, you get something else. They're not equal. So the restrictions are always on the original form of the expression. So, and you know I play this game, you know, plug in, you know, what is this thing equal if x is 2? Well, 2 is not a restriction. Well, that's easy to do. It'd be 2 + 2, 4, over 2 + 3, 4/5. Use the simplified form. Okay. Now, so this is your guide, has the steps. See if you can add these two. So, follow the guide. I'm going to go ahead and do this, but you should pause the video, try it, check your answer. All right, so I'm going to go ahead and look at this. I do not have a common denominator yet. I need one. I cannot figure out what the common denominator is unless I have prime factors in my denominators. So I'm going to factor out the a from that denominator. Then I look at my other fraction and I realize a minus 3 cannot be factored, so I just scoop it in parentheses. There's my factor. All right, so I have prime factors in my denominator, and maybe at this point in time, I'm gonna just note that a can't be 0 from there or 3. I may not ask you for the restrictions. They're always there even if I don't ask you, or potentially there even if I don't ask you. So now I need to build the LCD. There's no coefficient here, so it's just gonna be 1. And the different factors I see are a and a minus 3. The a only shows up as a, so that's how I take it in the LCD. The a minus 3 shows up as a minus 3 to the first in both places, so that's how I take it in the LCD. So that is my LCD. This first fraction, here's the denominator I desire, here's the denominator I have. I'm good to go. I don't need to mess with that one. The second fraction, however, is missing the a factor. So I will multiply top and bottom by a. Now notice how I didn't set it out as a separate fraction. I just multiply top and bottom by a. And you know, if I was doing my own homework, I'd probably just do that. Okay, when it's simple as that. The next step, I don't need to distribute in my numerators. So I'm ready to add. It's just 6 minus 2a, those are unlike terms, over a times a minus 3. So you add numerators. You don't add denominators, you just slap it over the common denominator. Don't box your answer yet. You should check to see if your answer reduces. It will not always reduce. It will reduce if your numerator is factorable, and after you factor, there's something you can cancel. So you gotta try. I see a GCF of 2. And you got a couple ways you can play this. Maybe I'll do it both ways. You could just take out the 2, and that would give you 3 minus a over a times a minus 3. And then you realize, oh, I got opposite factors, so that cancels to a factor of -1. It's not 2 minus 1, it's 2 times -1. So this is -2 over a. So that was one way you could have seen it. Back over here, you might have realized, hey, you know what? The a's are kind of reversed. I can always make my GCF negative, so I'm going to take out -2. And the -2 times 6, times what gives you 6? That's minus 3. I'm just going to put it back. -2 times what gives me -2a? That's positive a. And then what I notice is I have identical factors because I already pulled the negative out, and there it is again. It equals -2 over a. Okay. Now, You know I'm going to do this to you. Evaluate this expression. Recognize it's the one we just worked with. If a is 6. Well, do you really want to plug in 6 here? No. We just said this expression is the same as negative 2 over a. So I'm going to plug in a right there, negative 2 over 6. That's going to be negative 1/3. What if you plug in 1/2? That looks awful, but it really isn't. Certainly would be awful here, but these are equal, so I can just plug in 1/2 here. Be careful. I get this arithmetic error quite a lot. How many half dollars are in 2? 4 of them. Remember, this is the same as negative 2 times 2 over 1, so this is negative 4. What if a is 0? Well, this is where even if I don't ask you for the restrictions, you need to be aware. You plug in 0, it's undefined. Both of them are undefined. What if a is 3? Well, if you plug in 3 here, you will get 0 in the denominator. And as soon as that happens, it's undefined. If you plug in 3 here, you actually get negative 2/3. They're not equal. So that's why 3 is still a restriction. This equals doesn't hold if a is 3. So, this is not in the domain. You're not allowed to plug in 3. So don't do it. Now, one last thing I want to point out, which is kind of an add-on to these notes. I've done sort of harder problems, and there are some problems in your homework that might be something like this. 1 over x minus 1 plus 2 over x plus 3. Don't make these too hard. These denominators don't factor. So the LCD is just the product of the two, x minus 3 times x plus 3. Okay? It's very much like if you were adding 1/2 plus 1/3. These don't have any common factors. The LCD is just 2 times 3, which is 6. Okay? So I didn't do any easy ones like this, but there are some in the homework. Don't make them too hard.